Welcome to today's lesson. Today we're going to talk about color. Now every day we see lots of different colors. Today we're going to figure out a little bit about why. First of all, we know that we see things because light reflects off an object and it gets to our eyes. Now the colors that we see, those depend on what part of light is reflected and what is absorbed. Now what that means is you could have the same object and it's going to look like it's a different color when it's under different colored lights or different types of lights. So let's talk a little bit about light. The light in here from this projector, from the windows, the sunlight, from our lamps, it looks like it's white. But is it white? What is white? Well, here's what we did. We took a white light and shined it through a spectrometer, which broke it up into its different parts. And here's what we got. We got some blue, we got green, and we've got red. So what turns out is that white light is a combination of red light, blue light, and green light. Well, you might be saying, what about the other colors? Well, they're combinations as well, and we're going to talk a little bit about some of those. When you take blue and combine it with green, you get a color called cyan, which is kind of an aqua or a turquoise. When you take red and blue and combine it, where they overlap, you're going to get something called magenta, which is kind of a pinkish purple. Well, what about the last two, red and green? Now this one's surprising. When you put red light and green light together, you actually get yellow light. And you might be saying to yourself, this isn't what I know from kindergarten about primary colors or mixing. If I put red and green paint together, I am not going to get yellow paint. And you're right, you won't. We're going to get to that in a little bit. But first I'm going to show you how this all comes together. This is our red, our blue, where they overlap, it's magenta. Our green and blue, where they overlap, that's cyan. Our red and green overlap to yellow. And here you see where they all overlap, you get the white light. And I actually have an actual photo showing that this is indeed true. You can see right here, these are three spotlights, a red, a blue, and a green, and you can see where they overlap, and where they all overlap, it's white light. So let's talk now about what happens with paint, because combining paint colors or pigment colors, that's different. We're not talking about reflecting or transmitted light in that case, we're talking about what gets absorbed. So, we know that if we mix them all together, we're not going to get white paint. We're going to figure out what happens when you put red and green paint together, why you don't get yellow. It's all about absorption and reflection. So we'll talk about our red paint first. We have white light coming in, we've got the red and the blue and the green light coming in. What happens is the blue and the green are absorbed and the red is reflected to our eyes, so we see it as red. With the green paint, again we have the red, blue, and green coming in. The red and blue in this case are absorbed and the green is reflected to our eyes. Well, what happens when we put those paints together? What happens is the green paint is going to absorb all the blue and the red. The red is going to absorb all the blue and the green. So all three colors are absorbed. So you're not going to get yellow reflected to you. You're going to get kind of a blackish, brownish, yucky color because very little light is actually getting reflected to your eyes. It's all being absorbed. We're going to talk now about why things can look different under different lights. We have a beautiful t-shirt here. It's a yellow t-shirt, and when white light hits it with all of the colors, this shirt is going to absorb blue light. That means the red and the green are going to be reflected, and we found out that red and green light together make yellow, and we see yellow. Well, what if we take the same shirt, and instead of putting white light on it, we put cyan, so we're just going to have the blue and the green light hitting it. If we do that, we know this shirt, this material absorbs blue light. All that's left to reflect is green. So if we put this shirt under cyan light, what we're going to see is green. So that gives you a little information on how colors work. We're going to have a guest speaker now who's going to tell you a little bit more about it. Yo, how y'all doing? Roger Bibb is in the house. Give it up. You're welcome to my crib. My name is Roger Bibb, and I come here to school you about the colors where you live. You only see the colors that transmit or are reflected. And sometimes that means what you get, it ain't what you expected. Red, blue, and green, yo! Red, blue, and green, yo! Red, blue, and green, yo! Make up the white light that you see. The light we see is white. Yo, it might look white to you. It's really made of three colors, green, red, and blue. When they combine, it makes white light. It ain't so complicated. So sing along, it's my jam song, it's just what I have stated. Red, blue, and green, yo! Red, blue, and green, yo! Red, blue, and green, yo, make up the white light that you see. That's right. You know there's other colors, and I'll tell you where they're from. Blue and green make cyan. That's as aqua as they come. And now I'm going to take you on a colorful adventure. Blue and red light, they combine and give you that magenta. Now things go get funky, but don't go lose your mellow. Red and green light overlap, and what you see is yellow. The color that you see depends on light and what it do. You seen the truth, believe the proof. Now it's all up to you. Red, blue, and green, yo! Red, blue, and green, yo! Red, blue, and green, yo! Make up the white light that you see. Red, blue, and green, red, blue, and green, red, blue, and green, yo! Make up the white light that you see. Word.